in this video we're going to prove the product rule. So if you have a graph of let's say this line here is a product of u and v here. If you want to find out the true gradient at a, then you would get this height divided by this length here, which is h, and then take the limit of h as h tends to 0. So as usual, we would get we would put this into here, and then this into here, and basically this point here is given by this, and then take away this length here, which is given by this here, and then take the limit of h as h tends to 0 here. So the gradient of this product here is given by this thing here. Okay. The next step, we're going to so at the moment you can think of it as this is being one block here. This block here is this thing here. Okay, so this is exactly the same as this, and then this here is exactly the same as this. But what happens in between? Hang on. So this is exactly the same as this here, and this here is exactly the same as this here. What happens in between? It's like me saying, looking at what's up here, I'm just gonna in between these two. I'm just gonna. It's a bit similar to me saying I'm gonna add. I'm going to take away 3 and then add 3. So it's like me saying this here. If you have a minus b here over h, it's like me saying I'm going to a minus 3 and then plus 3 and then yeah, I'm just going to stick minus 3 and then add 3. You're allowed to do that. You're allowed to add a block, and then you're allowed to take away a block and then add a block. Okay, so basically I'm just going to take away this exact same thing and then add the exact same thing here. So this is like me saying I'm going to take away 3 and then I'm going to add 3. The whole thing here at the top, the numerator, will still be the same. You see, this thing here, it's the clever part is knowing that you need to take away this and then add the same thing here. This is the clever part. But let's just follow it through, and then at the end we will try and understand why it's clever. Okay. So basically this here is exactly the same as this here, and this here is exactly the same as this. So what we're going to do is we're going to so we're going to take away this thing and then add the exact same thing here. So we're allowed to do that. It will still, the numerator will still be the same. Okay, so the next step is, at the moment you've got one big fraction here. Okay, so let's break this up into two fractions. Okay, so break it up into two fractions. So this bit here is one fraction. Okay, and then this bit here is another fraction. So this fraction here is this here, and then this is this fraction here. Okay, and don't forget you got to take the limit of the whole thing. So so within this thing here you've got two fractions, one here and one here. So it's basically us breaking this thing up into two separate fractions. Okay, and then what? Let me think. Oh yeah, and then well, if you have a limit, well, again this comes back to our knowledge of limits. If you have if you're trying to take the limit of one thing plus another thing, you can actually break into the bracket, and this is all explained in the section on limits. So here you've got one fraction plus another fraction. You're trying to take the limit of the sum of you're trying to take the sum in a way of two parts here. So you can actually break in and take the sum of this, and then take the sum. Sorry, break in and take the limit of this, and then break in and take the limit of this here. So yeah, so that's what we're doing. We're taking the limit of this, and then we're going to take the limit of this here. Okay, and if you got to understand the section on limits. We've done all this before. So, well, take the limit of this and then take the limit of this. That's the same as you trying to take the limit of the whole thing here. Okay. So next step, hang on. So we are here now. So looking at this here. So remember, hang on. We were here, and then we take the limit of this thing, and then take the limit of this thing. That would then give us this. Okay. So now look at the numerator. You see this is in common. This is in common. These two are exactly the same thing. So let's factor out these two. So that becomes this, and then what's left is up here. Because if you multiply a fraction, it gets multiplied to the top, and here it's like you having this is A, this is B, this is C, this is C. It's like you having this here, A times B plus C over H. So when you multiply it, it goes to the top. So it's like this. This equals A bracket B plus C over H. So this thing here is like this part here, and we're just taking what's in common out. So here this is in common, this is in common. So factor the two out. So it becomes this, and what's left will be v x plus h, take away v of x here. So this whole thing here basically becomes this here, and then if you look on the right hand side now, this is in common, this is in common. Factor it out. Okay, factor it out. So basically this whole fraction here becomes this thing here. Okay, so now if again on limits, if you're trying to take the limit of one thing multiplying another thing, it's the same as you taking the limit of one thing and then timesing the limit of another thing. So here you're trying to take the limit of this thing here. So just take a limit of this, and then take the limit of this, and then multiply the two answers together. So here, take the limit of this. So that's this thing here, and then take the limit of this thing here. So that's this thing here. So whatever this answer is, and then whatever this answer is, later on multiply the two together. So that's why you've got this multiply here. Okay. Same with over here. Here you're trying to take the limit of this whole thing here. So just concentrate on taking the limit of this. Oh, by the way, this here, taking the limit of this is going to be the same. It's going to be the same here. So okay. If you wanted to, you can do this. Take the limit of this is the same as this here. Okay, so now take the limit of this here, because there's no h in here, so you can just take it out here like this. Okay, so this thing here, so it's you taking the limit of this and you taking the limit of this here. The limit of this is this here, so just concentrate on finding out the limit of this. Okay, so now if you take the limit of this here, as h tends to 0, this whole thing here will be u of x, because as h tends to 0, so here you've got x plus, so it's like you saying x and then x plus 0.0000000000001 01 here. So that's this whole thing here is just like u of x. Well, as you take the limit as h tends to 0 here, it's just going to become u of x, and then this here this is really our definition of a derivative. So this here is our definition of a derivative. So that this whole thing here is really u differentiating. Well, it's u differentiating v with respect to x. Okay, so this whole thing here is really the definition of a gradient in a way. Okay, this is the same as this, and then this here is pretty much the definition of the gradient, of the gradient of u with respect to x. So this is this block here. So basically, this whole thing, Yeah, this here is really the definition of the gradient, and then this here is the definition of the gradient. So so it then becomes this. So overall, if you're trying to differentiate, um, if you're trying to differentiate the product of two things, then this whole thing here is pretty much this thing here tidied up. So I've just tidied it up. That's all. So this is this, and this here is this bit here. This here is this, and this here is this. But going back to the start, the cunning part, the clever part was knowing. The clever part was this bit here. Hang on. We started out with our graph here. So it's going to be this divided by this, and then that would take us to here. And then the clever part was knowing that you've got to take away this and then add this. That's the clever part. The reason why we take away this thing and then add the exact same thing was so that we are able to get to this stage here. We are able to get to this stage here where we will get to our true definition of the gradient. The reason why we're taking away this block and adding the exact same block is just a trick. It's a trick that will allow us to get to something like this here. It's just a trick. Okay. So yeah. So the clever part was really knowing, take away this, add this. Okay.